In this problem, we're posed the following question. Suppose you draw a card from a standard deck. What is the probability of selecting a king or an even valued card? So in order to figure this probability, let's take a look at the probability addition rules. So if we take a look at the probability addition rules, we see for events that are mutually exclusive, and this means that the events cannot happen at the same time. If our question fits this particular mutually exclusive condition, then the probability of A or the probability of B will equal to the probability of A plus the probability of B. For non-mutually exclusive events, so notice that there is some overlap in these events, we would use the following formula. The probability of A or B, that's equal to the probability of A plus the probability of B minus the probability of A and B. So notice for non-mutually exclusive events, we have what is called overlap, where things can occur at the same time. So if we take a look at our question, it says, suppose that from this standard deck, what is the probability of selecting a king or an even card? These two events are mutually exclusive. That means that there aren't any even kings. You either have to be a king or you have to be an even card. So we have the probability of a king or an even card. That's equal to the probability of a king plus the probability of an even card. Now notice that there are 52 cards in a standard playing deck. They range from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice in this standard deck of cards, there is no delineation for the number 1. Unless you're playing a game that can force an ace to be a 1. Then we have jack, queen, and king. So first, let's figure the probability for a king. So if we find the probability of a king, we're going to set that up using our classical probability formula, where we have the denominator as the total number of cards to choose from. In this case, we have 52. We want to find the number of kings to choose from. So we have 1, 2, 3, 4. So my probability for choosing a king is 4 out of 52. Plus the probability of an even card. So once again, there's 52 cards in a standard deck. And out of our even cards, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we're going to add the two fractions together. Notice that we have a like denominator, so we're going to keep that denominator. I'm going to combine my numerators. 20 plus 4 is 24. 24 over 52, that reduces to 6 over 13. And 6 over 13 as a decimal is 0.462.